I'm recording, so I'm going to cross multiply. Okay, so if I put that over 1 and I cross multiply, I get the right side is x plus 1, and the left side is just x squared minus 1 times 0, which turns into 0. So then we solve it, and we get x equals negative 1, right? So we can say, oh, there's our answer. We cross multiplied. That has to be right. However, look at the domain of our original problem. According to the domain of our original problem, if we were to factor that denominator, x minus 1, x plus 1, because it can be a difference of squares, right? Then that tells us that x cannot be 1 or negative 1, because if it is, then we would be dividing by 0. So, even though cross-multiplying gave us this answer, which should be correct, it can't be correct because by doing that method, the 0 on the right canceled out the denominator, so it didn't really matter anymore, but it does matter from the beginning. So since it does matter, which means x can't be 1 or negative 1, and the answer we got is that x equals negative 1, we basically have to say that answer is extraneous and there's no solution. So no solution would indicate that this graph does not cross the x-axis. It's never going to be 0. So the last 3 little examples we saw are equations where it's equal to a number. We're finding where the graph crosses through that number, through the x-axis, or through the line y equals 4. But now we need to extend that idea to inequalities, where we're talking about whether it's less than, or greater than, or less than and equal to, or greater than and equal to, or things like that, right? So to solve inequalities graphically, we start by taking our equation and splitting it into 2 graphs. So one graph is going to be the left side of our equation, and the other graph is going to be the right side of it. And I guess not equations, we're talking about inequalities. I forget that those words are not interchangeable. Equation indicates they would be equal. Inequality indicates that it's not just a matter of being equal. There can be some ranges of values that work, right? Okay, so all this first step is saying is that left side of our equation becomes one graph, right side of our equation becomes the other graph. We are going to figure out where those 2 graphs intersect by solving where they're equal, kind of like we did on the last 3 little examples. Then we have to look more closely at it and figure out where the left side of the equation, so the graph represented by the left, is above or below the graph of the equation represented on the right. And then we use that visual representation from our graph to figure out what our solution is going to be. So if we look down here at example 3, I feel like we already saw this one earlier, didn't we? We saw this same exact problem, if I remember correctly, in example 1. Yes, we did. Okay, so we know already that the x-intercept was at x equals 1/2. Oh, I forgot that I was going to throw a word in here. I was getting this ready earlier and I left a blank for it. Use that domain. What's the word I was going to throw in here? To write the solution. So we look at where one graph is above or below the other graph, and then we use the domain of that piece to write our solution. Okay, let's do this. So we've got our equation, y equals 2x minus 1 over x plus 3, and we would have our line at y equals 0. So basically what we're saying is this is one of our graphs right here, and this is our other graph here. So left side of our equation, right side of our equation, correct? So this one, y equals 0, would just be our line here. And then y equals 2x minus 1 over x plus 3. We already figured out how to graph that earlier. I think we had an asymptote here and here. We had a couple of points. We know we had a point at 1/2. That's really the only one that really matters in this case. And then we also discovered that we had a point at negative 6.54. Gives us a better idea of what this side looks like. Okay, but what really matters is our red and blue lines. So the red is this left side of our equation, and the blue flat line is the right side of our equation where it equals 0. So now we're trying to solve where the left side is greater than or equal to the right side. So we're looking where is the red graph above the blue graph. So we've got this piece over here. This entire red piece of our graph is above the blue graph, correct? So that entire piece is part of our answer. So what would be the domain and interval notation for that piece of our graph? I don't like not having you guys able to answer me. Hopefully you're doing it in your heads or maybe just out loud to each other. Okay, so this piece would go from negative infinity to negative 3. Now look at our inequality really fast. Are we trying to do equal to 0 or not equal to 0? Wait. Not equal to an asymptote. It's never going to be equal to an asymptote. That has nothing to do with the fact that it's equal or not equal to 0. This has to be an open parenthesis, like here, because this graph can never equal negative 3 because of that asymptote that's there, right? Okay, so now the other part of our answer, I don't know why this isn't letting me draw. Okay, the other part of our answer then would be the part of this graph that is above the blue line. So we have this entire piece over here that is all above the blue line. But this piece here is only above the blue line from 1/2 and beyond. So I got a little ahead of myself when I started writing that second parenthesis there. What would be the domain that represents just that little red piece of the graph that's above the blue line on the right half of our branch? See how that would actually include the point at 1/2, because that's where it's equal to 0, and that's okay because our inequality is greater than or equal to 0. So we have a parenthesis around the negative 3 because that's an asymptote and it can't exist there. But we have a bracket around the 1/2 because it's equal to 0 at that point, and that is okay according to our inequality for it to be equal to 1/2. Then it's just the rest of that piece going forever towards positive infinity. So here is the solution to this inequality everywhere that the red graph is above the blue graph, not including asymptotes, but in this case including the x-intercept because it's equal to 0.